Black holes are craziest objects in the universe. So, how are they formed and what would happen if you fall into one? Stars are the battlefield of radiation pressure and gravitational force. Inside the stars, two hydrogen atoms are fused together and form a helium, releasing tremendous amount of energy. This causes the radiation pressure inside the core. In the main sequence stage, the two competitors are equally powerful and so the star holds its shape. The constant burning of nuclear fuel eventually stops as heavier elements are being created inside the core. Things get interesting after that. When the radiation pressure drops, the star starts to collapse, and after a certain time, a massive explosion or supernova occurs. The remnant becomes a neutron star, and if heavy enough, then black hole. They are the ultimate densest objects in our universe. If we could crush the Earth into a size of a peanut, keeping the mass same, then it would become a black hole. This is known as Schwarzschild radius and is given by this equation. Anything can be transformed into a black hole using the Schwarzschild radius. The gravitational force of a black hole is so intense that even light cannot escape it. Space-time is bent infinitely near black holes, and black hole would literally look like a hole of total darkness silhouetted against the backdrop of space, with the light from the surrounding environment being heavily distorted. Obviously, the accreting matter can be seen. There are several parts of a black hole. The photon sphere is a spherical boundary of zero thickness in which photons that move on tangents to that sphere would be trapped in a circular orbit about the black hole. For non-rotating black holes, the photon sphere has a radius 1.5 times the Schwarzschild radius. The event horizon is not a physical entity, but rather a region of space from which no light can escape. This is the point of no return. The black sphere in the pictures that we see is the event horizon. The center of black hole is singularity, a point where our understanding of physics ends. So, how does it feel to fall inside one? First, let us discuss how will you see an object falling into it. As time slows down near a black hole, you will see the body approaching slowly towards it. Light cannot escape event horizon, that's why we could only see the object till it hits the surface. Then it would be frozen at that place. Light emitted by the object would appear redder and dimmer. This is known as gravitational redshift. Eventually, the falling object fades away until it vanishes in the eternal darkness. Now imagine yourself going into the black hole. There are some speculations about your fate. You will experience things differently than an outside observer. For you, time will be flowing very fast. The gravity is so intense. The difference between forces attracting your feet and your head is so high that your body is extremely stretched like a noodle. This is known as spaghettification. Well, you are dead in seconds as your atoms will be shredded, but for the sake of imagination, let us think you are alive. Now, as you continue to fall into event horizon, you will see the rest of the universe within a circle and it will become tiny as moment passes until there is complete darkness. And to you, the whole scene will be blue shifted. It would take only few seconds from the moment you crossed over the black hole's event horizon for you to be crushed into bits. Actually, the smaller black holes are more lethal than the larger ones. But in the largest black holes, there's a chance that they lead somewhere else, to a white hole, to another universe, or to a new physical reality that's shrouded behind an event horizon we cannot see through. From the outside, we cannot obtain any information about what lies inside the event horizon. All we have are our theories. When an object falls into a black hole, any information it carried inside is lost forever, which gives rise to information paradox. But black holes are not completely black. In fact, they do radiate in the form of Hawking radiation. In the next video, we will explore more about it. Thanks for watching. Please like, share and comment, and to watch more videos, do subscribe.